Today I'm going to show you how to find the sine, cosine and tangent of angle 30 and angle 60. The method I'm going to show you is the method of using a triangle. In this case, we will have a process that begins with an equilateral triangle with each side equal. Normally, an equilateral triangle has this property that this side will be equal to this and this will be equal to the other two sides. Suppose each side has a length of 2 units. Now, because the triangle is equilateral, all interior angles of this triangle are equal and both angles will be 60 degrees. Now, to find the sine, cosine, and tangent of these angles, we need to have a right-angled triangle. And we can obtain the right-angled triangle by actually cutting this triangle into two parts. If we strike a line here, we will obtain an equilateral triangle with this side 2 units, this side 2 units, and this part 1 unit and this part 1 unit. In fact, the line is perpendicular to this line. This line which we have constructed here is perpendicular to this line. Now, let us take one of, before we take one of the triangles, let us check the size of these angles here. This angle here is divided into two. So here we have 30 degrees because the angle here is divided into two, and here we remain with 60 degrees and here 60 degrees. Now let us take one of the right triangles. It will be like this. This is 30 degrees, this is 60 degrees, and here you have 2 units and here you have 1 unit. What we don't have is the length of this side here. Let us call this length by any letter. Suppose the letter is x. We can then use the Pythagoras theorem to get the length of this side. And since the Pythagoras theorem states that the square of 2 adjacent sides equals to the square of the hypotenuse side, then we will have 1 square plus x square equals to 2 square. This is the sum of the square of the adjacent sides equals to the square of the hypotenuse side. We can then simplify. Here we'll get 1, x square, 4. If we take this to this side, you will have 4 minus 1. And this will be x square equals to 3. And then you square both sides, and then you'll get x equals to square root of 3. The square root of 3 is actually the length of this side. You can write it here. The next thing that you should do is to find the sine, cosine, and tangent of these two angles. Let us begin by finding sine, cosine, and tangent of angle 30 degrees. Remember, the sine, cosine, and tangent of any angles can be easily found by taking this relationship of angles and the sides of triangles. This is the simplest way. This is the simplest way you can use to remember these ratios, sine, cosine, and tangent of any angle. This ratio here means sine equals to opposite of hypotenuse, tangent equals to opposite of hypotenuse, cosine equals to opposite over. This is tangent equals to opposite of adjacent, cosine equals to adjacent over hypotenuse. Now, if we want to find the sine, cosine, and tangent of angle theta, come back here. To find the sine of angle theta, you need to use opposite over hypotenuse. Now, this side is opposite to theta, and this is the hypotenuse. The hypotenuse side is, remember, is that side which is opposite the right angle. The opposite side is that side which actually is right on the other side to a given angle. Now, sine of angle theta. Sine of angle theta. Sine of angle theta will be from this triangle. From this triangle will be opposite, which is 1, and hypotenuse is 2. Cosine of angle theta will be, by looking here, cosine equals to adjacent of hypotenuse. Now the adjacent side to angle theta is the square root of 3. Adjacent side is that side that is actually contributing into making that angle, but it is not the hypotenuse side. So this is the adjacent side. So cosine equals to adjacent over hypotenuse. So the adjacent side to theta, angle theta, is square root of 3, and the hypotenuse is 2. And the tangent of angle theta will be opposite of adjacent, and the opposite side to theta is 1, this one, and the adjacent side is square root of 3. Now, because you have a radical sign in the denominator, you should rationalize the denominator by multiplying this ratio with the number or the radical sign, the number under the radical sign in the denominator. So in this case, you'll have this value. Now, to find the sine, cosine, and tangent of angle 60 degrees, you repeat the same process, but in this case you use this angle here, which is angle 60. Apply the same ratios here, that sine equals to opposite over hypotenuse, and in this case the opposite to angle 60 is square root of 3, the hypotenuse is 2. Cosine is adjacent over hypotenuse. In this case, adjacent to angle 60 is 1, and the hypotenuse is 2. The tangent of angle 60, remember here we are finding sine, cosine, and tangent of angle 60, will be opposite over adjacent. In this case, opposite to angle 60 is square root of 3, and the adjacent side is 1. When simplified, you get square root of 3. You can tabulate these values. Here you have angle 30 and angle 60, and here you have sine, cosine, and tangent. Now, the sine of angle theta is 1 over 2. The cosine of angle theta is square root of 3 over 2. The tangent of angle theta is the square root of 3 over 3. And the sine of angle 60 is square root of 3 over 2. The cosine of angle 60 is 1 over 2, and the tangent of angle 60 is the square root of 3. So once you tabulate, it becomes easy to identify these values. Thank you for listening.